My name is Baljit, and I will be talking about a test solution which we use here at Yahoo to create a fully integrated, automated test environment for study point and testing different components of the ecosystem. So we'll have overview of solutions, and then we'll talk about what we are planning in the future for it. So as we know that there are over 13, 14 components which coexist with Hadoop code reproduced as DFS. To make sure that these components coexist and in a same environment, it's a complex problem to create such an environment for testing. So the challenges we face that if we can consistently create the same test environment repeatedly and install multiple, there are hundreds of packages to install our full Hadoop stack. So it also requires to set up schemas, and then the packages and which talks to Yahoo specific internal proprietary systems. And the biggest challenge is to make it automated so that with one button we can clear the whole environment and can run our testing. And also running these tests is the one thing, and running a different kind of test and certification was another challenge. To meet this one, Yahoo has a solution which we call it Deot, which stands for Hadoop Integrated Testing. So what does Deot do? It certifies the whole Hadoop ecosystem with one click. Meaning from start to end, deploying the whole system, running all the tests, and creating the test results and the certificate for the whole stack. So in the sample of all products, more than 15 components currently are on board in the head. Take Hive and all those 15 components, deploy all those into the test environment. And then it runs the integration testing, end-to-end integration testing of each component to make sure that all the system is integrated fully, and then it creates the reports and results for the whole testing. The system provides repeatable automated environment, which is selects a given predefined cluster and deploy the whole system on it. It does clean out all the nodes before it deploys it, and it also creates an isolated environment where it deploys the clients and the test packages, which runs all the testing for the Hadoop. It also deploys all the necessary databases required for running the tests. This is the basic structure of the deployment. It is a custom job, which is one click to start the job. It does create a isolated virtual environment, where it first deploys the clients, and then it does go ahead and clean up all the nodes, and then deploy the servers on specified nodes and use the data nodes for test to run the test on those. So every time we run this one click, every time we create the same clean, start from the same clean environment, and deploy all the required servers and clients and the test packages in a fresh environment. So in that way, it is always a repeatable same process every time. test results are stored in a separate directory where it's picked up by Jenkins and it's distributed. It's a failure or certificate is also created that time. Workflow basically goes through same as soon as the commit happens, it generates a package for any component which triggers the hit run. And hit run takes that version of that component and deploy. First thing it does is deploys all the components into the cluster, and which is the second part of it. And then it deploys the Git, which is a framework which runs all the testing and collect the data from different components. After deploying, it runs all the tests for each and every component and store the results. And then you provide those results whether it's all the components passed or failed, and then you can certify a stack. So you can certify one stack at a time, and the job is configurable. What it means is basically that each component, you can pick which component, which version of which component you want to run, which other component. So you identify those, and you can also identify which test you want to run. Like that's a selectable too. You can select whether you want to run integration, functional integration test for that component. You can run the whole, all the tests, or you can take whichever specific test, big test or high test you want to run for that whole stack. So what is the key value of this whole automated one-click test system? So it enables us to do the integration testing, and we run it before deployment or production or sandboxes. So it's a safety net before we deploy to our productions. It is a comprehensive platform, which means we can always repeat the same reference waveform any cluster we want. It empowered engineers basically to run their tests before commit. So they build their package and then just run Git in one click, which verifies whether the functionality and any it works with the whole as an integrated end-to-end test for that specific component. So it provided a solution for the teams which didn't have any test environment. They can just go ahead and build this environment and run their testing there. So it also gave us the same consistent environment to QE. So they deploy the same stack every time and run their testing. And we also use this as our entry and exit criteria for any component to be certified for. The future direction. So that was the UI we use for Jenkins, but in the future we are planning to have a command line interface, which is called HCLI. What HCLI will provide us is that each developer can sit, on their dev box after committing. They can just kick off a Hadoop job with the latest version of their packages. So by doing that, we can have a full process defined from commit to deployment using HCLIs. So this is a programmable CLIs. They can write their process and then kickstart the HCLI, the hit to certify their component or changes. contribution to the community. The plan is basically if we can, there are a lot of Yahoo specific component built into this thing. If you can separate that and provide the design of it for the community, we can use it as a one-button deployment and certifying the whole Hadoop stack. Any question?
Thank you, Baljit. Say that before we get into questions, I didn't want to create motivation behind doing this presentation. We get asked a lot as to how we run such large infrastructure, which is like 40,000 plus nodes, 70 times. We have a phenomenal operations team, but from a software development perspective, I think Kate provides us a lot of value before we roll out anything. And we constantly roll out software updates to one or multiple of these clusters either together or in sequence. And it provides that safety net that Baljit was talking about to make sure that production jobs don't fail once we upgrade it. Because we're very good at testing out individual pieces of software, but we never test the whole stack. So for example, if we make changes in the pipe, this sort of almost guarantees us that that's going to work with Lucy's post. For example, Lucy has a high action, we can overlay something in Lucy. All of the high developers says that it not work pretty well. It does provide us that safety net. So that's the value here. And we push a lot of confidence because it's very Yahoo specific. If you do want to use or look at something that's out in the emerging software foundation, something that I encourage you to look at Meetup, which actually assembles the stack as well, really in a very simple fashion to what it does. But it has a lot of these integrations to the backend components that are a little bit specific to Yahoo, which is what we're just talking about, why you can't readily make it available. Questions?
So, actually this question is a little away from the topic, but I just wanted to see if you have any guidelines for testing big stuff. And I've seen a whole bunch of jobs, and every time like make changes, it's hard to sort of do end-to-end for actually any sort of guidelines or any suggestions on that.
So, like I said, each component in the stack, any changes made to that component automatically kicks off it. So it is an end-to-end test framework. So it does test and certify it, okay, the changes and whatever you evaluated are ready to roll out. It is for a whole stack. That's the value of this, is that you integrate a whole stack and the biggest part of it. SCAD, hide, everything. So like I said, there are 14 components which we are onboarding on it. And every change get tested to it.
Yeah, to just add to what Baljit said, so Kate actually makes sure that Kate as such works with everything else in the stack. But if you're very focused on this test of Kate, I would encourage you to look at Kate unit. That's one. The other thing is working on actually the state mix. So it's similar to what Gradient does for it itself. And if you look at the event, there are lots of different functions, videos, those might be useful as well for you. But Kate unit is the answer, I believe.
Thank you. The question I have is, what is the turnaround time if you were to do regression test of all the tests that you create already?
Yeah, so like I said, we use this mainly for the integration testing, which is 4 to 5 hours and we made sure that each component does not exceed the half hour limit because these are integration testing, we're testing upstream components, the integration of what is up to the integration. But if we had to have regression testing run individually, it doesn't run all the components, it's run individual only, whole stack and then individual component run the regression test, which is varies from 5 hours to a whole day.
Thank you. Baljit, question I have is, what is the turnaround time if you were to do regression test of all the tests that you create already?
Yeah, so like I said, we use this mainly for the integration testing, which is 4 to 5 hours
How do you test for scalability, specifically, for example, hardware needs? Or is it handle something somewhere else?
It works on the predefined nodes. We use currently 20 to 30 nodes, 20 to 30 node cluster. But we can, those nodes are predefined into a role database, which we call Deot. And if we need to scale that, you can always define in the Deot all the nodes, whatever scale you want it, and then you can run it.
Yeah, it doesn't do scale testing, so it does integration testing, making sure that all components work together. In fact, to be honest, the way Hadoop's designed, we take scalability to the algorithm function and see that almost all components that we actually use in the infrastructure scales horizontally. Oftentimes, what you would find is that the scale limits are hit by either the namespace and the main node or other factors, but it's not designed to be scale testing.
Outside of heat testing?
Actually, outside of the heat testing, which is more of a functionality of the stack testing, you do have a separate environment where performance testing is standalone done by a performance team. So just wanted to add that.
More questions, so then go to the...
All right, thank you.